Alright guys, we're on to the next section of 7.2. Actually just recorded this and my video got deleted or got corrupted because my computer, I don't know what happened, there's like a default in the middle of recording. So I lost a 20-minute video and I'm just ranting to you guys right now about that. So if I'm a little less energetic, then that might be why. I'm sorry. Okay, so we're at 7.2. We're continuing on to problem number 6. Before we do that, we do need to talk about how to calculate this z sub x bar. Although even though I say we should know how to do this, there is a way around it that I'm going to show you. So what I'm planning to do, we have 4 questions on this page, right? 6 through 9. I'm going to do it first using the zx bar, and then I'm going to do the problem skipping that step and showing you a way around it. Now, even though the book will typically tell you how to do it using the zx bar because they expect you to use a standard distribution table lookup, but we're not using tables because that's too much trouble. So I'm teaching you the easier way, I think. Anyways, we should still know where it comes from, what it is. This is a standardized version of our x bar, which is our mean, right? If you remember when we calculate z-scores, what we do is we take our value, we subtract whatever the mean was, right? And we divide by the standard deviation. Now, in our case, what is the value? We're looking at a particular value as being the mean of our sample. What we're subtracting is the overall mean. And when we say overall mean, what we mean is the assumed overall mean based on H naught. So you know when you do these hypothesis testing, what we're actually doing is we're assuming H naught is true to start with, and then we're seeing if that is a true hypothesis or not. If we were correct, then with high probability we'll get the right thing. If we were wrong and the hypothesis is wrong, then with high probability we'll get the wrong thing. Right? So okay, anyways, coming on. I'll continue on. Standard deviation would be sigma, but in this case we're talking about the sigma of the means, the standard deviations of means. So sigma sub x bar. If you remember back to a previous section, sigma x bar, that's just the original sigma divided by the square root of the sample size. Yeah. And then the top is the same thing, x bar minus mu. All right, this is a pretty important thing if you're going to do it using the standardized version. So you know on your first page, we talked about previously, 7.2, first page of this chapter section that is. I would write a note here, right under number 3, where it says compute the sample standard test data statistic. I would just write down this note right here at the top, or not top, but next to it. Z sub x bar is equal to x bar minus mu divided by sigma over the square root of n. That's just what we have right here. I just broke it down further for you. Now this over here, I'm going to leave this in the top left corner because we're going to use that at least for the first 2 problems. And then this time I'm going to break up the video so I don't lose another 20-minute one. Let's just do 6 and 7, and then I'll start a new video for 8 and 9. Okay, number 6 first. So the claim is that mu is equal to 40, alpha is 0.05, sigma is 1.97, and the x bar is 39.2, and n is equal to 25. All right, notice right off the bat, n is less than 30, so that means we might have a problem. We have a problem because it's not 30 or more. That means we aren't guaranteed normal distribution, which means we can't do anything unless the population is normally distributed. Now, if you look at the top of the page, it says right here, assume the population is normally distributed. So, okay, we're safe. We can go ahead and move on. Now, this is how I suggest you always start. Kind of like how we started in section 7.1. What is your H naught? What is your H alternative? And what is the tail test that we're using? H naught first. That's the one that includes equality. So the H naught is mu is equal to 40, which means the alternative is mu is not equal to 40. Not equal means we're doing a two-tailed test. So when you see two-tailed, what should be in your mind is this picture, a sketch of this picture. Here's our z values, and we're looking at the size of the tails on both sides. Yeah, the probability of being in either one of those, so combined. All right, now let's figure out our z value. Z value is going to be the mean, 39.2, minus the true mean, 40, divided by the standard deviation, 1.97 over the square root of 25. Now when you plug this in, I suggest using parentheses so that you don't mix up the order of operations. That's the neighbor just passing by right now. Okay, 39.2 minus 40 is negative 0.8. Divide that by, in parentheses, 1.97 divided by square root of 25, which is just 5. Okay, so I plug that in, I get, this is the x bar. The x bar is equal to negative 2.03045 or 5. Okay, now for the probability calculation. So now I have the z-score. The p-value then is just going to be equal to, since I'm doing both sides, I should do 2 times, let's just pick the left side, 2 times negative 10,000, negative 2.0305, 0 is the mean, 1 is the standard deviation, and just see what I get. So 2 times norm CDF, negative 10,000, negative 2.0305, 0, 1, 0.04, 23, blah, blah, blah. But the important thing here is that this is less than 0.05. Right, so since it's less than 0.05, I'm going to erase this so I have some space, this picture. What that means is I'm going to reject my H naught. Reject H naught. So since I reject H naught, then that means I'm going to accept its alternative, that x is not equal to 4. One thing though, the claim is actually that that mu is equal to 40. So since I reject H naught, what I'm really doing is I'm rejecting the claim. So I rejected the claim. Yeah, that's it. Let me kind of break down the logic behind this. So what we do is when we're testing a hypothesis, we assume that H naught was true. We assume that it was true that mu was in fact 40. And then with that in mind, we're trying to figure out what's the probability that if the mean is 40, what's the probability that I'll get some particular x bar value that I got? Well, the probability of that, or somewhere to the left of that, or to the right of its something that's this far away. What's the probability I'm going to get something that's this far away from my mean, given these circumstances? And the probability turns out to be really small, right? 0.04. So in other words, it's very unlikely that you would get this average, assuming that the assumption was true, assuming that you really had a mean of 40. So since it's really unlikely that would happen, then we reject that hypothesis. Okay, I'll kind of go over that same logic again in each problem so we can sort of drill it into our brains. Let's do number 7 now. Okay, so the claim this time is that mu is greater, strictly, than 1745. Alpha is equal to 0.10. Sigma is equal to 32. X bar is 1752, so larger than the claimed mean. And n is equal to 28. So right off the bat, I'm looking like it's probably going to end up probably that we're going to accept the claim, is my thinking, because if you look at the value, it's larger, right? So if you claim that mu is bigger than 1745, then it seems like plausible that the mean of a sample, small size, would be bigger than 1745. So right off the bat, it looks like, okay, it seems like we should accept that claim. But let's see what the hypothesis test says to be completely accurate. So first of all, H naught and H alternative. The one that we're given is the alternative because that's the one that does not include equality, right? So it's mu greater than 1745. So the original one was less than or equal to 1745. This is the one that we assume to be true. We're assuming H naught to be true. That's how we always do these things. And this is here the claim. Yeah, the second is alternative is the claim. Now, for deciding which tail test we should use, we always look at the alternative. The alternative is to the right, so that is what we're going to use. We're going to use this one on the right side, right? This is the picture that's in your mind. We want to know the probability of being out in this area over here. Okay, so first the z-value though. The z-value, zx bar, is our value, 1752, minus 1745, divided by standard deviation over the square root of n, which turns out to be, let's plug this thing in and crank it out, 1752 minus 1745 equals 7 divided by, in parentheses, 32 divided by the square root of 28, which is 1.1575 roughly. Okay, so now I have my z-value. Then we do the same thing as usual. We're going to do the p-value calculation, which is equal to, now we're looking at the right side, right? So right side, it should be norm CDF. This here is the lower bound, 1.1575 to 10,000, comma 0 for the mean, 1 for the standard deviation. Let's plug that thing in. So norm CDF, 1.1575, comma 10,000, comma 0, comma 1. And I get, oh, wait. I typed that in wrong. 1.1575. Okay, I got 0.1235, which is bigger than my alpha, which was 0.1, right? So bigger than that means we do not, or we fail to reject H naught. Is the lingo that they use. Fail to reject. Okay, I'm not really a big fan of this, actually, this language. And, I talked about why they do it at the beginning in 7.1. But really, I think it's confusing, and I don't really think it's all that necessary. I feel like you can just say you're essentially accepting H naught. If you fail to reject, essentially you're accepting. Although technically that's not true. We could actually rearrange the question and just change equality to inequality, and then we could have gotten basically the same conclusion that we would accept H naught. So that's kind of just my own personal gripes. Like statisticians, though, they're very particular about this language. So if you want to be completely proper, then you should say fail to reject. But in my mind, I'm thinking fail to reject, that means you're basically accepting H naught. And if you're accepting H naught, then what that means is you're rejecting its alternative. So you reject HA, right? Sorry, this is kind of getting squished. It's kind of hard to see. So let me erase this and rewrite that last conclusion part. So failing to reject H naught means, I'm going to just recopy this down. Fail to reject H naught. Sorry, my arm's in the way. Fail to reject H naught means we're going to basically accept it. So let me write that in parentheses. Basically accept. And what does that mean for alternative? Remember, alternative is the complement. So that means we should essentially reject the alternative HA. But more like technically speaking, we are failing to accept HA. Now, which one was the claim? The claim was HA. So we're failing to accept the claim. That means we don't accept the claim. Like I said, I'm not really a fan of the language. I would just say you reject the claim. You don't accept the claim, so you're really just basically rejecting it, right? All right. That is that. I'm going to stop this video now so I don't lose another long one. Or it's kind of long already. And then we'll do 8 and 9 in the next one.